Micrometry Curves allows the user to calculate more organic shapes that are different from straight lines. The program starts very similar to its counterpart micrometry lines. It contains a scale bar, and we still need the micrometer. We can use it to take a value of reference to real units. And in my case, I'm gonna use the left button of the mouse to start a segment, and I'm gonna use it again to confirm my selection, and then I'm gonna press 0.1 for the real unit of measurement that this micrometer gives me. Once I'm done, I will press enter. At this point, I'm gonna change the micrometer and I'm gonna change it for an actual view of a biological sample. With my sample in place, now I can start using and tracing Bezier units. Bezier units are common in programs that require editing vectors and curves. They are used to create something called splines. Let's suppose that I have this filament right here, and that looks actually quite perfect. I'm gonna try to make a measurement to see how long it is. However, a straight line in this case wouldn't be very useful. I click on the Bezier button, and then I can click in the first position where I want to start taking measurements. Before I do so, I also notice that some specimens can move around quite often, and maybe they can move the filament. So I'm gonna press escape, and in this case, I'm gonna make use of the button called freeze. Once I freeze the image, I can enter the Bezier units again, and then I can left click with the button of the mouse on a static image, and then notice that at this point, what I have is a segment, just like a straight line. I'm gonna go to the middle of the curvature at the inflection point when it starts going the other way. However, this time I don't release the mouse button. Instead, I keep dragging outwards, creating a counterpart line that ends with a dot, representing the point of gravity that is pulling the otherwise straight line away. And I can leave it right there to make sure that it matches the curvature of my object. Once I'm ready, I lift the left button mouse and I confirm my selection. The previous position of my cursor will now become the new gravity point for the next curve that I need to make. You can see now that the curvature is twisting accordingly to the prediction of the shape that I am tracing right now. This is now a Bezier spline. I can click again and confirm my selection. There's multiple ways of confirming and interacting with these spline lines. After the first one, any other spline line can be confirmed by just clicking with the left button of the mouse, and instead of dragging, I just release immediately. I click and release. That will confirm a curvature that is kept as predicted by the program. If I don't want to continue with the delimitation of the curves, I can press D. That will confirm that the spline has been completed, and now I can save it. I can call it anything I want. Let's call it test 1, and I can press enter. That will save the value. And then I'm brought back to the original program. Let's find another sample. Here we have a portion of an algae. I'm gonna freeze the program once more, and I'm gonna repeat the process. I left click with the mouse to start the selection, and then I drag it downwards to create a curve. I'm gonna keep the mouse clicked, and I'm gonna drag it away to create the auxiliary points that represent the points of gravity of the Bezier spline. Once it is done, I can release the button and confirm my selection. However, this time, the prediction of the program is not very accurate. You can see that the point of gravity in the new element of the spline is all the way over here. What I can do instead is to click once more with the left button of the mouse, but this time I don't release the button. Instead, I repeat the same process as I did in the first curve, and then I can click and drag. That will reset the gravity points. I can drag it somewhere over there, and then I can confirm by releasing. and then I just repeat the process. Something interesting about this is that you can also create lines. Let me show you how. For now, I'm going to cancel this selection. I start with the Bezier option and I click and drag to the right. And then I just click and release once more. And that confirms my selection. I press D and I ended up with a straight line. Just as before, I can call this anything I want, and it will be automatically saved by default in the subfolder Measure Curves that came with the program when we cloned it from GitHub. I'm gonna double click in the output.txt, and here I can see the measurements. The tags that I added to them, in this case, the value of the curves in the real units, the date when they were created, and the time. If I wanted to change the path in which this information is stored, I can set a new path. I can click in Set Path, and I can specify the name of the txt file in which I'm gonna place the different measurements. I'm gonna call this Test Curves, and I'm gonna press Save. If I repeat the process by creating Bezier curves, I'm gonna press D for done, and in the demonstration, hello world, I press enter, and this time if I go to the folder that I just specified, there will be a file.txt that contains this information, test curves, and here we can see that the information was successfully stored. Picture works in a similar manner. Once I have specified the path, I can simply click on Picture, and that will store a screenshot, quote-unquote screenshot, of the image that I just took. Notice that a new folder Images has been created in the path that I specified. If I double click in there, I can enter and I can see the image that I took when I press that button. If I wanted to take photos that show the curvature and the values of the curves in Bezier units, I can click on the Bezier unit again, and then I'm gonna need to freeze the image. I'm gonna press Escape, click on Freeze, go to Bezier, and I'm gonna create a very quick and dirty approximation once more. There it is. And what's the perimeter of this algae? Something like that. And I can close it right there. So in this case, to take a photograph, I can press D to specify that I am done, and press the key P in my keyboard. That will capture an image and it will save it, displaying its value. Before we conclude this tutorial, I need to present to you a very interesting mode that comes with OpenCV that allows for motion detection and, at some extent, edge detection. First, I'm gonna unfreeze the images, and then I'm gonna click in this button that reads Edge Mode. If I click on it, you will notice that the entire screen goes black. What we are looking at right now is a Boolean mask that gives a value of white for every pixel that represents motion and black otherwise. You can see that a value of a background is calculated or averaged over multiple frames. Anything that I do in the microscope that is otherwise static, like for example changing the elevation in the z-axis, will reveal the edges of my specimens, which is particularly useful for some scenes that are particularly dark or hard to detect. This filter that works at the level of individual pixels is quite useful. To go back to the original image, you can click RGB mode. Keep in mind that all of the attributes that we saw before work exactly the same whether you are in RGB mode compared to edge mode. I can freeze the image, I can go to Bezier, and I can also calculate and take images of the different elements that appear in my scene. If I go back to the images folder, you will see that the image is saved with its Bezier curve in the edge detection mode.